But the answer to that is no, but I will put a worksheet on for oxidation reduction reactions. As soon as I know my computer is safe to, it's not gonna let me look the entire college website and stuff. Okay, so but we were talking about oxidation reduction yesterday. If I'm looking at this equation, we've got copper here. What's our charge on the copper?
What's the charge?
On this copper? Okay, it's a transition metal. So how do we figure out what the charge on the transition metal is? By what it's combined with. So the sulfur we know is a -2.
So it has to be a +2.
Well, this is +2, but then
was
each copper is +1, because I've got 2 coppers.
Okay.
Okay with that? So this is a -2. This is a +1, and it's ×2. So that we have a +2 on this side. But the overall charge of the copper, or the oxidation state of the copper, is +1. Okay, what's the oxidation state here? I guess I should put
0.
0, because it's by itself. Copper here? 0. And how about these?
That's +2.
It's +2 total, but each one is a +1, and then it's a -2. So then, if we look at it, we've got copper going from a +1 down to a 0, and we've got hydrogen going from 0 to a +1. In order for copper to go from a +1 to a 0, what's it actually done?
Gained electrons.
Gained electrons. How many? It gained, each one gained 1. Or gained 1 electron. But I've got 2 coppers doing that. So we kind of do this. Okay, so I've got 2 coppers doing that. If I've gained electrons, am I oxidized or reduced? Correct? I've undergone reduction. Okay. Still the hydrogens. What's happened to it?
Lost electrons.
It has lost 1 electron, so it's been oxidized. And I happen to have 2 of those. Okay. So then the balanced equation for this, I need to have 2 coppers on both sides and 2 hydrogens on both sides. I've got 2 coppers here, 2 hydrogen here, 1 copper here. I need to have 2, and then 2 hydrogens here. And now we balance that by oxidation reduction. Not too bad? Is there anybody out there that don't feel about oxidation reduction the same way I do? Alright, try this one then. We've got Fe plus Cl2. What's it going to yield? Well, I guess I have to tell you what it's going to yield. Okay, there. Because I didn't give you the oxidation state of the iron. Okay, so we've got iron. Its oxidation state, it's by itself, so that's 0. 0. What about here?
That's gonna be, is it iron 2?
Iron's a transition.
Must be iron 3.
It's got to be 3.
Plus 3.
And then each chlorine is minus 1, but I have 3 of them. So, iron has gone from 0 to plus 3. So what's it done?
It,
Oxidized.
it
Lost it.
It's oxidized, and it's lost 3 electrons. How about the chlorine? We've gone from 0 to -1. So it's been reduced, right? Okay with me? But I've got 2 chlorines, so it's gained 1 electron each, but times 2. So it's actually gained 2 electrons total. So what I need to do then is balance a common number for 2 and 3, which is going to be, what's the common denominator for 2 and 3? 6. So then for every iron, I'm going to need to multiply it by 2 to make 6 electrons total. For every chlorine, I'm going to need to multiply it by 3 to make 6 electrons total. So to balance the equation, every iron needs to have a 2 in front of it. And every single chlorine needs to have 3. So a total of 6 and 6. And it really is not that much different than balancing non-oxidation reduction wise. You're just looking more at the loss or gain of electrons. I still don't necessarily see a whole big point to it. Okay with that? Not rocket science? All right. Now, when we get into oxidation reduction with up till now, what kind of bond would this be? Do it? Now let me get back up there. There's another way to balance these things. Using half reactions. Okay. So if I've got something like this. Remember way back when we talked about net ionic reactions and net ionic equations and what reactions were actually taking place. You remember yesterday I was also talking about how in Chem 1 we'd done a reaction where we took aluminum foil, put it in solution of copper chloride, and the aluminum and copper traded places. This is kind of a half reaction. Really all we're worried about in this case is the aluminum and the copper trading places. We're not going to worry about the copper chloride solution and the water and all that kind of stuff. What is going on in this equation is we've got aluminum that's at 0, and this copper's 0. We put in copper 2 chloride solution, but we're really only worried about just the copper ions. Those have a +2 oxidation state here. They came out by themselves. They took the place of the aluminum and the aluminum foil. So they came out by themselves, so they have 0 state, but the aluminum then went into solution with the chlorine, and at that point it became ionized and had a +3 charge. Did I just turn into the Charlie Brown teacher? Okay, let me back up. When we took the aluminum foil, and if we did this, if we wanted to do this, we could, and we took the copper chloride. Then what happened in the experiment is the copper came out of solution and the aluminum went into solution with the chlorine. So there's the overall reaction, but with this, all we're really worried about is the two things, the metal ions that traded places, this and this, and what happened to them, which is this reaction up here, and how they changed oxidation state. Okay, so it's just that reaction up there. And we're just going to balance it that way. So what we do is we take the aluminum, do the same kind of thing we were doing with the other oxidation reduction reactions. We're going from 0 to +3. The copper, we're going from +2 to 0. Anything else that's in the reaction, we're not going to worry about. We're just dealing with the metal ions that have actually traded places. So, what's gone on with the aluminum?
Lost electron.
It's lost 3 electrons. And what's happened with the copper?
Gain 2.
It's gained 2. So again, what would be a common denominator of the number of electrons? 6. So we're going to multiply every aluminum by 2, and every chlorine or copper by 3. So what this says then is, to balance this equation, we're going to have copper by 3. Yep. Aluminum by 2. Yet again, kind of a pointless type of balancing equations, but I've got to show you how to do it. This is balancing by the number of electrons gained and lost on both sides.
So in order to do the redox, you have to have like that many moles of aluminum? Okay. In order for
To balance the electrons gained and lost. Again, to me, it's much easier just to balance equations the old-fashioned way. But this is representing what really happened. In order to have, if we had 2 moles of the aluminum going in and 3 moles of the copper going in, that means we've got 6 electrons here trading places and 6 electrons here trading places. That aren't going to have trading places. Okay. And this is called using half reactions. Did y'all go into this at CSU? Or Kelly, did y'all go into this much of it?
I don't think so. I don't think we went over half reactions.
I can understand why. Okay. So let's try another half reaction. Alright, we're going to take zinc and iron. So zinc plus iron. So this zinc is being put in by itself into a solution of iron something. We could call it iron chloride if we wanted to, but it's something that's got iron ions in it. The reaction occurs, the zinc reacts with whatever the iron was with to form an ion, and the iron comes out by itself. So you can think of it like this if we want to. It would be some kind of reaction kind of like that. But again, bless you.
Thank you.
We're just dealing with the metal ions. Okay. So what's happened with the zinc? Zinc, we've gone from we've gone from 0 to +2. So it's lost electrons, lost 2. The iron, it's gone from +3 to 0. So it's gained 3 electrons. So the total number of electrons that we need on each side is going to be 6. So 3, 2, 3, 2. That's all there is to it. You want every question to be like that, right? Alright. And apparently you can do this with, I don't remember going into this stuff in grad school, but this is using half reactions to balance acidic solutions. Okay. So we still do the same kind of thing. You look at the iron. We're going from what are we doing here?
That's what the thing needed.
Well, let's just look at the two different reactions first. Okay, so we're looking at this. We've got, you're going to balance elements other than hydrogen and oxygen. And then you're going to add water to the side that needs O's and H's. Okay? So what we're going to do here is we're going to balance this by putting a 2 in front of it. 2 negative 1s, 2 negative 1s. All right? The 2 chromium atoms are balanced with this. So we're balancing each individual half reaction. 2 irons, 2 irons. 2 chromiums, 2 chromiums. Back to the old-fashioned balancing equations. Huh?
Iron or iodine?
Iodine, sorry. Did I say iron? Okay. Now, how do we balance the water and we're going to add 7 waters to the product side. Okay, and why I'm doing that is to balance these oxygens. So I added 7 waters over here,
So you need to
and we're gonna have to add
one
in
H2s.
14 hydrogens over there. Okay? Then we're gonna balance the half reaction for the charge by adding electrons to the side with a more positive charge. Whatever the hell. Alright, so which side has the more positive charge?
The one with the hydrogen.
Product side?
Actually, we're gonna go over here and do this. Remember, they're 2 separate half reactions. Alright. This is more, we're looking at this is more positive, so we're gonna add the 2 electrons there. Okay. So how many electrons? You know what, this is just.
I'm completely lost.
I am too. I've got myself lost in this because I don't understand why we're doing all this. The way it says, okay, what the steps are, it says to write the 2 half reactions for the equation, which we did here and here.
Mm-hmm.
Okay, then we balance elements other than hydrogen and oxygen in each half reaction. So, we don't have to do anything, we don't have to add any hydrogen or oxygen here. I've got two iodines here, so I had to put 2 iodines here.
Where'd those electrons come
I'm
from?
gonna get to that. Let me back it up. Backing the bus up. From the get-go. Alright, so we've got iodine, 2, iodine, 2. We've got this, to this. Those are the 2 half reactions. Okay? So now we're going to balance the elements. So up here, I'm going to balance that. Down here, I'm not going to deal with the water right now. I'm just going to balance the chromiums. So to get the chromiums balanced, I'm going to have to do this. This seems like more trouble than it's worth to me. But. So now we've got the iodines balanced in one half reaction and the chromiums balanced in the other half reaction. Now then, we balance water. We use water to balance the side that needs the oxygens. So basically we do the chromiums first, the iodines and the chromiums first, then we worry about oxygens. Since there's 7 oxygens over here, I'm going to add 7 waters here to get my oxygens balanced. Then I'm going to come in and add the 14 hydrogens.
How can we add 14 hydrogens instead of 7 H2?
Because that's what it says to do.
Okay.
Because we're balancing just the H ions, not the diatomic element. Okay. Then it says balance each half reaction for charge by adding electrons to the side with the more positive charge. So the charge of -2 here is balanced by adding these 2 electrons here.
Yeah.
So now we're worried about balancing electrons. Okay.
Well, the water can be +3, 2.
Now then, we have a charge of +6 is obtained on the reactant side by adding 6 electrons here.
Alright, now you just lost me. I followed you up until that point.
Okay, it says a charge of +6
Oh wait, I see.
is
No,
obtained
no.
on the reactant side by adding 6 electrons.
But it's
So if
not.
I've got +1 or +14,
-2 is 12. -6 is 6. Okay, no, it balances. It does.
okay? So then we have add balanced half reactions, canceling electrons, combine waters and H's.
Okay.
Really?
So,
Alright. So we've got, the way it shows it in here
you
is,
should cancel your 2 and keep 3.
now it's, hold on. I missed a step. Okay, then it says multiply, before we even do that. We're at this point,
Mm-hmm.
and we're at here.
Mm-hmm.
Multiply each half reaction by factors that equalize the loss and gain of electrons.
So you should just have to multiply the top by 3.
Exactly. So now I'm gonna have,
6.
I'm gonna write it down here, 6 iodines yields
3 by
3I2 plus 6 electrons. I will include this on the worksheet, but I will work some examples for you.
2.
Give you an example to go by. All right?
I'm still confused. Where did the 3 come from?
Which
To balance
okay.
out the electron charge.
On the top you have negative 2 electrons, and then on the bottom one you have 6 electrons.
So you put in 3 to get 6.
So you add 3 to get 6.
I need to have the same number of electrons on both sides. Yeah, I know.
It's just add an extra thing to balance.
Okay, okay, so we got the 6 by multiplying 3 times the 2 at the top, the 6
Mhm.
iodine.
Mhm.
And the 3 came from, with the 2 extra electrons on the, what is that, the product side? And you just added over.
Because we had the 6 electrons over here, we needed to end up the product, the reactant side. We needed to also have 6 electrons on the reactant side. And the way we're gonna do that is by it's a little disconcerting when security comes and starts looking in your window. But then he started blowing me kisses, so okay. All right. So, what we're ultimately trying to do is get it to the point where we have the same number of electrons on the product side and the reactant side. So whatever I put in, I gotta put out,
Okay.
including whatever is going on within the actual reaction.
Okay.
All right? So now, ultimately what we have is these 2 equations. So then we add the balanced half reactions. So we're gonna have 6E negative plus 14H positive plus Cr2O7 negative 2 plus, we had 6I over here, yields, ready for this, 2Cr plus 3
Plus 7 waters.
plus 7 waters plus I2, 3I2 plus 6 electrons. So I've added this and all of this here. Or actually this. And then this and all of this on this side.
I do have one question.
Okay, hold on.
Okay.
We can balance, we can take out the electrons.
Well, what's the point of putting them in there?
Huh?
What's the point of putting them in there?
To get the electrons balanced from side to side, and once you get that balanced, then the equation's balanced. What was your question?
Okay, so on the top,
Uh-huh.
when you, I see where you add the 2 electrons over there because you've got a -2.
Right, you've got 2 times -1.
And then on
And
the
this
other side is
basically
0
had-
and
yeah.
-2.
Mhm.
On the bottom though, wouldn't it be +6 and then you added a -6 to the other side with the electrons?
Electrons are always negative,
Yep, but I don't understand why you put the 6 electrons on that side.
because how many did we have over here?
Wouldn't that be a
We-
+6?
We had +6.
And then the water's 0.
Why is the water 0?
Isn't water 0? Isn't it -2 and +2?
Okay. But then we had to balance out what we added. We had to balance the hydrogens from the water that we added over there to balance the oxygens.
Mm-hmm.
So then we had an excess, we had -2. Why would we do that? Because that's.
Oh, does it come out to be +6? Cause the 14, the hydrogens are positive, right?
Right.
14 minus 2 minus
14 minus 2 is
Yeah,
12,
it is,
minus
it
6
is
is
positive
6.
6. Okay, I
Okay.
see.
Okay.
You with me?
Mhm.
Because this is plus. So it's 14 times +1 is 14, minus 2 is 12, minus 6 is 6.
Mhm. then
And
the
over
other side
here
is
we
positive
have
6.
positives, we have 6. So you gotta get the same number on each side,
Okay.
same number of electrons. Just like, and then when we had this, we had to get 6 electrons on either side as well. Because this is -6, I mean, that's a -1 from up here. So 6 times -1 is a -1. This is 0, so I had 6 over here.
Oh, goodness. And it's okay to just leave it as hydrogen ions?
Hydrogen ion here, yes.
Yeah.
Because that's what we actually added. We didn't add H2, we added hydrogen ions. All right. Do you want to try another one?
Wait, let me write that down.
I'm gonna try it with the basic one this time. Did you?
So the whole point of this is to get rid of the electron and balance it.
Is to balance the equation by balancing the electrons in each half reaction.
Question.
Mm-hmm. What's the point?
That and will this ever come in?
Well, like I said, we never even did this in grad school. I don't know why the state standard tortures you with this stuff, but it does. I vaguely have nightmares about it from undergrad, but that was 30 some odd years ago. And y'all are the first Chem 2 class that we've been able to get this far. Because I didn't have to go back and cover stuff that I didn't cover in Chem 1, because everything you needed I covered in Chem 1. Okay. So yeah, I'm a little rusty on this, but it's coming back like a bad nightmare from 30 some odd years ago. All right. You good?
I think so. Okay, so 6E plus 15H plus.
And base ones are done pretty much the same way. So I'll run through one of those. Do it. I will be kind, I promise.
Or one that we worked.
Do it.
Or one that we worked.
Oh, that's ugly.
All right. Let's try this.
I picked the wrong day to skip coffee.
I picked the wrong day to only have 1 cup. And then to have my, you missed the story. Did you miss the story about my morning class?
Oh, Lordy.
It's always something with that class.
The worst part was, like I said, I didn't know if the schizophrenic student had shown back up because I had my back turned.
What? He's back?
No.
Oh.
No, I had a student completely freak out about a bug. Apparently she's terrified of bugs. And a bug landed on her. She launched out of her chair. When she did, she caught her foot in her backpack and fell on the floor, which set the dog off.
Oh, yeah. I forgot you got the
It isn't over yet.
Yeah, the dog started barking, which then freaked out the entire back row in the classroom. And I look, and okay, I'm like this, and I don't see what's going on. All of a sudden I turn around, and there's 4 students in the back corner, all like on chairs.
Oh my God.
See, know what you meant.
Yeah. Okay, so now we've got the reaction. We need to write the 2 half reactions. So we've got iron going from +2, let's do this. We've got iron going from +2 to +3. And we've got NNO4 going from -1 to basically 0. Everybody okay with that? Okay. So the iron is, we're not going to deal with losing and gaining reactions right now. Gaining equations, gaining electrons. What do I need? Which one do I need to add water to balance the oxygens?
The product on the bottom one?
The one on the bottom. And we've got to add it to here. So how many do I have to add? So now I've balanced out my oxygens by adding 2 waters. But I've got 4 hydrogens, so I'm going to put there. Okay. So now we've balanced the oxygens and the hydrogens of the bottom one. Now we've got to balance the half reactions by adding electrons to the one with a more positive charge. So if I'm looking at this, then I've got to add 1 electron there. And then on the bottom one, I've got to add, let's see, I've got 4,
You got 3. So
minus 1 is 3 over here.
Mm-hmm.
And here I've got
0 and 0.
0 and 0, so I need to
Add 3 electrons to that side.
To that side, so now I've got 0 and 0. Everybody okay with that?
Mm-hmm.
Why did you add 3 electrons?
Okay, because on this side, so it's not confusing. At this point, if I add up my charge, I've got 4 times positive 1, so for a +4 and a -1, for a +3 charge total on this side.
Okay.
Over here, I've got 0 and 0. Neither of those have charges. So how am I going to go from a +3 to 0? How am I going to get this side to be 0 too, or as well? The only thing I do is add 3 electrons to it.
Oh, to make it 0?
Right,
Okay. I see how you.
to make both sides 0. Alright? So we're okay at that point.
Mhm.
Okay, and then we've got
Multiply top by
+2
three.
and +2 on top, do we?
Yeah.
+2 and 3 minus 1 is +2 and +2 and 0 and 0. So, now we multiply each half reaction by factors that equalize the loss and gain of electrons. So, if I've got to multiply this
The whole thing by 3, right?
by 3 up here. So now I'm going to have 3 electrons on this side, and on the top one that gives me 3 electrons on the other side. Okay, if I've got 3 electrons here, by multiplying this equation by 3, I now have 3 electrons on the product side as well. Alright? So now I've got 3 Fe plus 2 yields 3 Fe plus 3, and then plus 3 electrons. So I've got 3 electrons here and 3 electrons on the product side, or the reactant side, and 3 on the product side. So now I add all the half reactions together, which is going to give me 3E negative plus 4H plus NNO4 minus plus 3Fe plus 2. Everything? Okay. And then on the reactant side, I've got MnO2 plus 2H2O plus 3Fe plus 3 plus 3E minus.
And then your electrons
Bad time to
cancel.
not bring a second colored pen. So my electrons balance cancel out here and here. So then my ultimate balanced equation is 3Fe plus 2 plus 4H plus
NNO4.
how would I do that? Yep,
Put
gotta
it
do
in
it.
the base.
You gotta put the base. To write this oxidation reaction in a basic solution, we will neutralize VH pluses
What?
Mhm.
With OH?
with OHs. So we're gonna have now, the electrons disappear, but we're gonna have this cancel out.
I picked 4OH negative because there's 4H plus.
Mm-hmm. Added 4OH here to neutralize this because it's in a basic solution. If I add it here, then I've got to add it here.
That would be the only difference?
Hmm?
That would be the only difference?
Mm-hmm.
Okay.
Then we can cancel the waters because this combined together would be
4H2O.
So I can cancel 2 of these with those. So the ultimate final damn thing is this.
So, the 8 steps.
That's our final answer, Regis. This came from this. And just like in algebra, whatever I do to one side, I gotta do to the other. Combined like terms with this and this. I still had 2 waters left over here, still have the 4 OHs over there. So that's balancing a half reaction, basic solution. We will do some more of these tomorrow. Okay. If it's completely confusing right now, don't worry about it. Other than we've got, let's see, +2 charge here. 6 minus 1 is 5. And then 9 minus 4 is 5. So we have the same number of electrons still on each side. We've got 6 minus 1 is 5 total. And then we've got 9 minus 4 for 5 total.
I'm confused as to why it's, if there are electrons, why is it positive?
There what?
Electrons, why is it positive?
That's which positive?
Because you've got 3 plus 2s,
3 times 2.
yeah, times
That's the charge.
positive 2.
So it's
So wouldn't that be 5
lost,
protons?
it's lost 5 electrons, but gained 1. It's lost 6, but gained 1. So it's still got an overall charge of 5 electrons, 5 gained, 5 lost. Okay. And 5 lost here.
So they lost the same.
So we're doing
electron.
oxidized reactions. Or
This
as
one, no,
both
this
of them.
was on page, the last couple I worked were on 498 and 499. Acid solution, basic solution, the process is basically the same until you get down to what kind of solution to the very end. We will work these some more tomorrow.